Okay, so today we're going to talk about one of the compression algorithms. We're going to talk about run length encoding, and we're going to talk about the properties of run length encoding, how you do it, and when to use run length encoding. When is it good to use RLE and when is it bad? Okay, so run length encoding, first of all, is a lossless compression algorithm. So just to remind you, lossless compression algorithms mean that when we decompress them, when we decompress the file, we have exactly the same quality that we started off with. Okay, it's lossless. And basically what it does is it takes its original data and breaks it down into something called frequency value pairs. One thing to know, and we'll talk about what frequency value pairs are in a second, it can either operate at a byte level or a bit level, and we'll talk about that in a few seconds time again. So if you imagine we've got this image, okay, this is our little bitmap, and I wanted to think that this is a 8-bit color lookup table, okay, so that we have, even though we're only using two colors, so white and black, white is 0, black is 1. Okay, so then our bitmap behind this image would look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros for that row, and then 1, 2, 3 zeros for that row, and then 1, 2, 3 ones, and then 1, 2, 3 zeros. Okay, so when you lay them all out in a row, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros, and then 1, 2, 3 ones, and then 1, 2, 3 zeros again. Okay, so this is the first two rows of this bitmap. So all run length encoding does is it says, well, I've got 12 zeros here, so instead of writing out 12 zeros, I'm just going to write 12 and then comma and then 0. And then I've got 3 ones, so I'll write 3 comma 1, and then I'll write 3 zeros. So if you think that each one of these here is a byte, you know, because we're using a 8-bit color lookup table, this data here, 1, 2, 3, 4, well, it's going to be 18, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 18 bytes here. Okay, so the file size here would be 18 bytes. Using run length encoding on the first two rows, we're only going to use 6 bytes. So we've compressed 18 bytes down to 6 bytes. Okay? Run length encoding works well when the file contains a large number of values that are the same. Okay? So if you have an image which has big areas of exactly the same color, then RLE works very well. The other pros to RLE are that it's very easy to code RLE. Okay, so if you as a coder have to develop a compression algorithm for some reason, RLE is a good choice because it's actually quite an easy algorithm to implement, and it's an easy algorithm to put together for the decompression too. It's also a very quick algorithm because you're just basically streaming through the bits and checking to see if it's the same as the last bit. So it's very quick to encode and it's very quick to decode. So those are the pros of RLE. The cons, if there's a lot of different colors or a lot of different values in your file, then RLE can actually increase the size of your data. So for instance, imagine we've got a bitmap which is 010101. Okay, when we RLE encode that, that's going to be, I want one lot of 0, then I want one lot of 1, then I want one lot of 0, and then I want one lot of 1, and then I want one lot of 0, and then I want one lot of 1. So an RLE encoding of this data here produces this data, which is considerably larger, it's twice as large. When we have files that have lots of different values, RLE can actually increase the size of the file. So you need to have a rough idea of the values of the file before you decide to use RLE. Okay, so that's a brief overview of RLE. If you have any questions, feel free to contact me. Other than that, I will see you all soon.